week. Do enjoy the next presentation.
Good afternoon, everyone. Welcome back. We are now in Hall 3 for the next session of today's sessions. My name is Mohammed bin Sifon. I'm Chemscience Consultant Sdn Bhd. On behalf of the organizer, we would like to welcome you all to Hall 3 again, and I will be moderating this session. Our next topic shall be by NX Filtration, with the title NX Filtration Extract, which will be presented by Mr. Allan of NX Filtration, Southeast Asia, Australia, New Zealand, and China. And for that, as well, yes, we have a colleague of NX Filtration by Lintelo. Before we go into the session, I'd like to introduce both of them. Allan is experienced head of operations based in Southeast Asia with a demonstrated history spanning over 25 years, working in capacities in chemical, mechanical, and industrial aqua engineering industries. Well skilled in water infrastructure engineering and treatment construction, membrane separations, management, and international project experiences. Allan has designed, supervised, and built many membranes plants and offered solutions in Southeast Asia, especially in Malaysia for both municipals and industrial plants. Whereas Rick T. Lintelo, NX International, he's Dutch-born, global leader with more than 20 years of experience operating in an international environment with extensive knowledge of both technical and commercial aspects, ability to provide strategic vision and direction, whilst assisting and improving clients' member application. He has been lauded as a maker of differences in all the organizations in membrane science. Rick has worked in and understands Southeast Asian markets for membrane applications with international companies. Ladies and gentlemen, the floor is with Allan and Rick Lintelo. Thank you.
Hey, good afternoon, everybody. My name is Allan, and I'd like to say hello to all my friends in Malaysia. I wish you a very good afternoon, and thank you for joining us in this. I don't know about you guys. I'm based in the in the northern part of Singapore, and it's a wet and rainy day. With me today, may I just introduce my colleague and a good friend of mine, based all the way in Netherlands in Enschede. His name is Rick T. Lintelo, and he is the International Business Director for NX Filtration. And I'll put the floor to him so that he will say a few words and introduce himself. And of course, the much awaited presentation of who we are and what we are in NX Filtration. Rick, over to you.
Thank you, Allan, for the nice introduction. And thank you to the organization for allowing us to give a presentation here on NX Filtration. My name is Rick Lintelo, and I'm based in the Netherlands. It's not rainy. It's actually a nice day here in the Netherlands. It's colder than at your place. I hope everybody is safe under these conditions today. And I would like to say a few words about our company, NX Filtration. And for that, I would like to start up the slides. Not sure who will bring in the slides.
Do I share my slides again? Or? Okay, let me try this. Rick, are you seeing it?
Yes.
Okay, over to you.
So both Allan and myself work for NX Filtration, and on the next slide we will give a short introduction about our company. NX Filtration is actually still quite a young company. We have been established in 2016, and we are a spin-off of the University of Twente, which is also based here in the Netherlands, in Enschede. And today we are with over 50 colleagues around the globe already, where Allan and his colleague Venkat are two of them based in our Singapore office. It's a fast-growing company, and since the 11th of June, we have also been listed here at the Amsterdam stock exchange. So we are a listed company as of the 11th of June, and we are very proud of that. And with being listed, we have gathered a lot of capital to make our the growth which we have foreseen in the coming years possible by investing in a new state-of-the-art factory here nearby our current offices, and expanding on both sales and sales support, pilots, R&D, etc. Although that we are still a young company, we have already established quite some nice references around the globe, which Allan will tell you more about that later on. The uniqueness of our company is that although we are very young, we have more than 100 years of experience in our company, and our founder, Erik Roesing, which you see here in the middle, who used to be my colleague in our former company, which he was the co-founder of X-Flow in these days from the 70s. He still had an idea, a dream, and a mission to develop an hollow fiber nanofiltration membrane. But this was the missing link within the whole chain of membrane products, water treatment products available in the market. And Erik started back in 2000, well, a long time ago, 2013, but also before, with this new innovation. And in 2016, it was commercialized by means of NX Filtration. And in the group, he was joined by a lot of experienced people on all aspects what you need in a company, from sales to R&D, to production, etc. You see here some of these names. Next slide, please. So the range of products we have, I mentioned the hollow fiber nanofiltration membranes. Well, we also do microfiltration membranes for wine and beer clarification and food and beverage applications. The general ultrafiltration membranes, which everybody knows, who is a perfect pre-treatment for RO, etc. Mostly used in desalination pre-treatment and other applications. But for us, our focus and the unique product is our hollow fiber nanofiltration membrane. And on the next slide, it's a little bit scattered that you see the different types what we have. And for us, it is the focus is on the DNF40 and the DNF80, which is a 400 and 800 kilodalton, 400, 800 Dalton membrane. And you see here what the filtration objectives are, and that we are capable of removing in one single step the different aspects which are in the water. So not only the viruses, the bacteria, and the suspended solids, which we are also able to remove the colloidal silica, but moreover, color, organic materials, dissolved matter, and even the divalent ions we are able to remove from the water. The next slide. All of this is very innovative, and that's innovations are running through our veins, and of course you cannot be innovative without having everything patented. So a lot of our production steps are patented. The layer by layer technology is patented to protect the uniqueness of this product. Next slide. So everything, and Allan mentioned it already, I'm based here in Enschede in the eastern part of the Netherlands, and everything what we do is produced and developed in the Netherlands here. We have at the moment 2 offices, 2 production locations, and in the near future then we will move to our state-of-the-art new factory, and we do the whole membrane spinning and coating here in Enschede. Of course, you need to control the process, quality, etc. And we produce the modules as well here in the Netherlands. So all is made in Holland, and that gives us, that makes us very flexible. And that creates a lot of innovation power also with the combination with the university here. And it's easy to scale up our production as we become more successful. Next slide. You cannot do all of this without being ISO certified, which we are, and also to have a number of certifications, drinking water certifications, which we have in our portfolio, like NSF, like the Dutch and the German drinking water approval. And we are working on more drinking water approvals, like the French and the English DWI, and more to come after that as well. Yeah, next slide. Yeah, sustainability is very important nowadays, and when we went to the stock exchange, we also have been listed by the Cicero with a dark green label, and that is for us a very important label to be assigned to us. And the dark green, we are the first one to receiving this dark green label, and that is on one part because we are in our we want our customers, we want to support our customers in the whole chain, in the reuse, creating clean drinking water, supporting the industry with reusing wastewater, and contributing to a better world. But besides that, we also want to be very sustainable in our production process. So on one side, we are using green chemistry in our production process to produce our products in all aspects, but also we are supporting by that our membranes are operated chemical free. So that means that we are using no flocculants, no coagulants, no antiscalants if you use our products in the field. We are also very energy efficient, and that contributes to a very low CO2 footprint. So our membranes operate at very low pressures and very low energy consumption, if you compare that to other technologies available in the market. So on the one hand, we try to be very sustainable in our own production process, producing our products, and on the other side, from an operational point of view, we are trying to also support our customers with being very sustainable, and that creates very low OPEX. Next slide. So this was my introduction to NX Filtration, and I would like to give the word now to Allan to make a more deep dive into our products and the applications where we are already successful today. And once again, I would like to thank you for being here today during this presentation, and once again the organizers for giving us the opportunity to show our unique hollow fiber products, nanofiltration products. Thank you.
And a very good afternoon again to all my friends in Malaysia. So here I go. I'll take control of the presentation now because well, we are in Malaysia after all, yeah. So we want to make sure that we have an Asian skill sets to actually give you some offerings and share with you our case studies and so on and so forth. Now what Rick has mentioned is our direct nanofiltration. Yeah, we definitely have more than huge amount of years of history, going commercial in 2016. In the 2016 till now, I just want to share with you some of the opportunities that we are currently doing. Yeah, where are we now? We are now looking into attacking and removing, microbiology, the colors, heavy metals, and even hardness. Now, what we are is very, very unique, ladies and gentlemen. We are now nanofiltration. Yeah, for those of you who are aware of, you have the MF, then you have the UF, followed by nanofiltration, and then you have the reverse osmosis. Globally, we are having a lot of customers coming to us and saying that, okay, ultrafiltration, it's perhaps too open. You do not remove certain dissolved components that is inside the water. while reverse osmosis removes too much. Yeah, it removes minerals that may be useful for the requirements and so on and so forth. And well, fortunately, both of them, UF and the RO, use a lot of energy. Alternative technologies are definitely around. You have ozonation and activated carbon. Now, okay, first of all, caveat, yeah, UF and RO are great technologies. They've been around for a long time, yeah. Likewise for ozonation and activated carbon. In the past, the markets are aware that the UF and RO are spiral wound. But if you listen to what Rick has mentioned, our uniqueness is that our nanofiltration technology is now hollow fiber. Yeah, I repeat again, it is interestingly because we are absolutely different from the previous technologies, which is using spiral wound. Okay, Rick has mentioned, yeah, we got quite a few range of technologies, yeah, and we'll be spending a bit more time talking about this. Yeah, I won't talk about the UF, I won't talk about the MF. I'm sure that you guys in Malaysia have used it plentiful already. Traditionally, as I mentioned earlier on, membranes, especially for our friends in the nanofiltration and the reverse osmosis, the membranes are based on spiral wound. That means they are wrapped up in a with spacers, and then after that they have a collector tube and so on and so forth. Now, basically, I've added in a small little simplified flow diagram. You have a lot of feed tanks, you have pre-filtration. Then the water goes into the buffer tank before they actually you have a pressurized you have a pump to pull the flow through. So basically for the UF, you probably run at 1.52 bar pressure, and then probably at the NF and the RO, you're running about above 6 to 7 bar pressure. But generally, we are running in most cases between 3 to 4 bars. That's where Rick mentioned earlier, we are really, really, really low in energy and carbon footprint. So compare the two designs, you can see very quickly. Yeah, hollow fiber. Our hollow fiber, just a little bit more information. We are inside-out flow membranes. So you can see from the flow diagram, it is a lot simplified. And Rick has mentioned, just with a simplified pre-filter and things, voila, you have clean filtered water. A bit more deep diving into a little bit of our membranes. Take a look at this. Yeah, we are one of the thickest membranes, hollow fiber membranes in the world. And what's important, you can see our inside out, you can see the graded density of how our fibers are actually created. You can see it is very dense on the inside, and then after that you have the special coatings, yeah, our nano coatings, and then after that you can see that the graded density where the water comes out from the inside out. Oh, for those of you who are asking, what's the material that you guys are using? We are using charge support PES, polyether sulfone. So deep diving a little bit more. Conventional technologies, you have the chemicals, you have the coagulants, you have followed by the clarification, and after that you have the filtration, polished up with a UF and further polished with ROs and yada yada yada. But what we are doing is we are now bringing and patenting to the world is that with NX filtration or direct nanofiltration, it is just one simplified step, adding a strainer and directly into the nanofilters. Isn't it? I hope that this is wonderful for you, because this is going to reduce a lot of capex. It is going to reduce a lot of land space, which in many cases in Malaysia, as the country expands or the water treatment expands, the water need expands, the water treatment plant is actually fixed in size. So with nanofiltration, direct nanofiltration, you have a possibility of reducing the footprint and yet increasing the water flow. Okay. Going a little bit further, this slide is prepared for you, okay, for Malaysia actually, yeah. Obviously, you have drinking water for removing the hardness and the TOCs levels in the water. In industries, yeah, I've put down some industries over here, yeah, but one industry that I've not added inside here is the semiconductor, which we are very pleased to share with all our Malaysian friends that we are already starting to look into water industries, especially semiconductors in Penang. As you know, Penang, there's a lot of semiconductor manufacturing opportunities, and a lot of these semiconductor manufacturing opportunities are using a lot of UF and RO. So with our one-step technology, we are actually able to bring down capex costs and increase the reliability of our solution for people. Yeah. Malaysia is, there's a lot of talk with Indah Water and so on and so forth about recycling of the wastewater. Lots of things that are going on over there. I will not delve too much about it, because I believe in this week you have heard a lot from other presenters and likewise from Indah Water as well. Great opportunities abound in the wastewater discharge, and a lot of them, especially I just use Top Glove for example. They have been one of the success stories in Malaysia. So they manufacture the rubber gloves and so on and so forth. But did you know in the wastewater process, that's a lot of micropollutants from the rubber? Think about it. What if these micropollutants goes into our surface water? Well, good news, nanofiltration removed that for you. Okay, I'm going to go next into case studies. I'm working very hard to find opportunities in Malaysia for all our OEMs and all our water treatment partners. So the next few slides, unfortunately, I really wished. I have family in Penang, I have family in Johor. I really wish to actually done something in Malaysia, but in the pandemic situation, many of my opportunities or many of my case studies in Malaysia are not moving as quickly as I want them to be. But nevertheless, I'll be sharing to you some case studies that I've done in Southeast Asia. Plenty of opportunities have already taken place by us. Again, around the world, we are Southeast Asia, in Singapore, and I used to travel a lot, before the pandemic, up and down Malaysia. Some of the opportunities have been done, but I would like to ask you to see, countries that traditionally we're talking about, your membranes are expensive and so on and so forth. But if you notice, countries like Vietnam, Philippines, and Indonesia, which has been notorious for water being polluted, are already beginning to use our membrane technology. Well, these three countries also tell you that if they can afford it, I'm sure in Malaysia, we are definitely able to join you guys to offering you opportunities. And interestingly, if you look at all the plants that we've built, the biggest one we have built is actually in our southern neighbors, Indonesia. To first start, Davao. Well, this is the hometown of the president of Philippines. They have, Philippines, as a lot of us know, they have a lot of rainfall, especially during the monsoon season and the typhoon seasons. Unfortunately, a lot of their water, similar to my moderator in Chixiphon, where like Sarawak is, a lot of the water in Davao, they have a lot of vegetation plantations. For all of you, for all of you who eat canned fruits, the peaches or even the pineapples, the bananas are coming from the Philippines, are actually grown in the Mindanao area, where Davao is also part of it. And the groundwater, unfortunately, with all these plantations, have already been laced with the humic acids. Humic acids, for those of you are aware of or not aware of, humic acids cause the brownish color or the dark color, like teh or kopi, color into our surface waters. And with our nanofiltration membrane, you can see one step, no pre-treatment, we remove. And one more thing, zero anti-scalant as well. We remove 99% of the color, in fact almost 100%, because the color counts we have measured is at 0, but being nothing is being 100%, we always put down as 99%, and a very high recovery of 80%. snapshot a little bit more. Yeah, if I just showed you. The color of the feed is on the right-hand side, on the right-hand side bubble. And you have the product, which is, as I mentioned to you, crystal clear. And you can see the concentrate. It's the concentrate, which means this is the waste reject, which is now looking like coffee. And a snapshot of one of the trains that we have installed on the left-hand side. This one here, I just wanted to show you that, yeah, we are consistently doing above 80 to 80 plus recovery, and our quality is at a very, very good level. Of course, what we talked about one step in Asia, I just want to switch a little bit back to our opportunities in the Netherlands. This is a project that is done in Enschede, which is in, like Rick said, the eastern part of Holland, in which they are doing surface water. But you see the surface water is on the left-hand side where Eric is holding. That's the color of the river. And after the filtration of our membranes, again, 0 chemicals, single step, and we are able to produce European grade, WHO grade, international grade drinking water, and still 80% above recovery. A snapshot of what we have done. Yeah, remember we mentioned, Rick has mentioned, we remove the divalence inside the water. So do not expect us to be like a full RO and reduce it to low conductivity or low TDS levels. But here we are, but you can see the rest of the stuff we are actually removing. Now, this is the biggest plant that we have that we are currently very proud of. This is done. This in the city of Dumai in Indonesia. For those of you that have been there, okay, a lot of us actually go down to the city of Malacca in Malaysia, and then we take a boat over to the city of Dumai. I've done that for several years, as I've done quite a fair bit of projects in this part of Indonesia. This is a very unique, yeah, in Indonesia, because Dumai is so-called like the mecca of the palm oil industries. Yeah, I know Indonesia and Malaysia, they're always fighting on palm oil, who's #1 and so on. But this is one of the largest palm oil refinery areas in Indonesia. And the uniqueness is that so much of the water has been taken into the refineries for boiler feed and so on and so forth. The citizens and the people in Dumai, they don't have water. They actually have to truck water almost 3 to 4 hours away from another city. But it's not because they don't have water. They have a main river, as I mentioned to you, the Masjid River. Sorry, what I mean I mentioned to you is that, but the Masjid River is the same problem, like Davao. It's very badly colored by the rotting vegetation that's in the palm oil and so on and so forth. I think this is quite similar to what we have in Sarawak as well, where the humic acid causes the color to be very bad. And what we have done is that same thing, one-step solution, removal of the colors with no chemicals, with more than 80%. So I just want to give you an example of what we have done. So the feed in the center, the product on the right-hand side, the reject on the left, and this is what we have done during the piloting stage. And you can, as you can see here, the color is absolutely crystal clear at 0. This is a snapshot of the plant. From the pilot, we have moved on to a large plant, and this is now one of the largest membrane filtration plant in Indonesia at this moment, using direct nano filtration. Now, enough of drinking water. That's something that, you know, maybe people are looking at the new things and say, oh, Allan, you shouldn't be talking so much about surface water. But okay, what about wastewater? Let's do this. Okay, on wastewater in Europe, yeah, the conventional wastewater treatment plants, like, I mean, it's likewise in Southeast Asia as well. Yeah, we use a lot of clarifiers. We use the normal technology to treat our wastewater. But what if this wastewater can be recycled? And this is exactly what we have done in this opportunity here in the Netherlands. What's different from from the technologies that we have shared is that the UF do not remove the microplastics. The RO, they do remove, but not everything. But surprisingly, nanofiltration actually removes a tremendous amount of these microplastics that are dissolved inside the water. Okay. Moving a little bit faster because we are running out of time. Yeah, in a wastewater treatment, you see the nitrification process and so on and so forth. But what we have done is that we have short-circuited it, and to produce now these costs are taken from in European pricing. Yeah, it all really depends on the cost of labor, the cost of energy, the cost of chemicals, and so on and so forth. But in Europe, this is about, to treat the wastewater is about 0.5 to 0.6 euros. I know that these numbers are not aligned to what we have in Southeast Asia, but you can generally know that you're going to be a lot cheaper than if you do it in Malaysia or in Southeast Asia. Moving a little bit more, comparing ourselves with similar technology without mentioning brands, you can see that in our hollow fiber nanofiltration, we are removing a significant higher amount of micropollutants. In this case, we're talking about organic micropollutants. In Malaysia, of course, we will not forget, our friends in aerospace. In aerospace, in the moment we talk about aerospace or aeroplane, we talk about AirAsia. So, in a lot of the aerospace industries where planes are actually manufactured, in this case, this is American Aerospace. So, without mentioning brands, you should know which brand I'm actually talking about. They use a lot of clean water to actually clean the aeroplane parts and so on and so forth. Why RO water? For some of them, for those of you who are not aware of, is that they use RO water is because they want it without static. Normal water, you can cause a lot of static in the metal parts and all those things, and which may spark off in the plane engine, and that's a no-no. So RO water or treated water, highly pure water, is actually used in parts to clean many of the parts of the aircraft engines. Again, our membranes are used as a pre-treatment before the second pass RO. Yeah, for those, okay, because we're running out of time, I'm going to move a little bit more faster. In Penang, for example, we are talking to a semiconductor industry because the normal parts are using it as they're using softeners, they use carbon to remove the chlorine and so on, then followed by the UF and a double pass RO. With our DNF technology, we are able to shortcut it down to just raw water from PBA, Penang, goes through a coarse filter of 150 microns and straight to our DNF membranes, followed by one pass RO to create, okay, of course, there's a polishing of using multimedia resins and so on and so forth. But what we had done is that we have actually short-circuited the process and improved the process by removing the softeners, we remove the UF portion, and we remove the first pass RO. That's a huge cost savings in CapEx and, of course, still energy for the semiconductor industry. Yeah. Moving a bit quicker, this is a plant in Canada, in which soft drink manufacturer, starting with brand P, is actually using our membranes to actually recycle the wastewater and to recover the sugar syrup. Yeah. And this opportunity, the reason I brought this up here is because in Malaysia, there's also a lot of food industries in which, sugar, for example, the sugar discharge, the sugar waters, the sugar color, and for those of you who are aware of, in the sugar industry, if let's say you use chemicals to bleach the sugar to make them white, then you may not be able to sell it into the European or the American markets. But if you use membrane technology as a sustainable nature of creating sugar, then you're able to sell it off to the European markets as well. Okay, a lot more, yeah. Fishery, tanneries, food discharge, and so on and so forth. This is something that we have been doing a lot as well. And I'm looking for opportunities here in Malaysia for this time being. Okay. So yes, we mentioned, yeah, our technology is new. So in order to show ourselves as something that our membranes are actually working, we have produced different pilots to loan to our friends who are interested. So in this is the case, this is the lab scale where we are able to produce up to 2 liters per minute for you to bring it to a lab, bring it to a laboratory to get it tested to show that the water quality is okay. For those of you who needs a medium size, of course, we have a larger one, which is a mid-size one. We call it the Experience. And this produces up to 700 liters of water in a what we call a 4-inch module. And for those who want a larger pilot, we have it in a full scale. This is our full commercial scale model, in which is a full 8-inch module, in which we are producing up to 2,000 liters. And this can be containerized, so it can be shipped to anywhere, into other parts, so you can move from one place to another place easily. This is a snapshot of what it looks like in a container. So, conclusion, DNF, low OPEX, no chemicals, low fouling, and simplified process for all our Malaysian friends who are looking for opportunities into improving their water design, their water treatment design. Yeah, just a typical one. Yeah. Okay, and this comes to the end of my presentation. I rushed it a little bit because I wanted to give the chance to the audience on the floor to ask me some questions. So again, I'd like to thank the organizers for this opportunity, and I'll leave it to you to now to have any questions that I can pick it up with you guys.
All right, thank you, Allan and Rick, for the presentation. We are now opening the floor to live question and answer, for which we probably can allow around about 2 or 3 questions due to the time limitations. And the questions shall be queued to both Allan and Rick for the presentations. Some of the questions that can be queued now are perhaps Allan or Rick can clarify that as much as there are references all over the world, are there any demonstration or piloting membranes of the end of NX in Malaysia, Allan and Rick?
Okay, hey, thank you for the question. That's a wonderful one. As I mentioned to you, we have started, yeah. NX have started to look into Malaysia in the last couple of years, yeah. And unfortunately, because of the pandemic, a lot of the opportunities have been slowed or scaled down or are not running. For example, right in your country, right in your state in Sarawak. Like I said earlier mentioned, yeah, we are looking into PT water filtration, because there's a lot of rivers and streams in the part of Sarawak where the water can be actually filtered. The PT water can actually be filtered and actually fit enough for Sarawakins' water consumption. That is one project that we are currently doing. Yeah, we're looking into. Obviously, I mentioned I've earlier mentioned, yeah, First Silicon in Sarawak is one of my first projects that I've done as a water treatment engineer. We are also trying to talk to them about using our direct nano filtration into replacing the traditional UF and RO configurations, or the hero design, as a lot of you of those in the ultra pure water. due to NDAs, I can't announce what I've been doing in Penang. But yes, we have talked to quite a few semiconductor industries looking at this technology. Likewise, we also tried to talk to our friends in the southern part of Malaysia, in the city of Johor, because again, you know, likewise during the drought situation in Malaysia, water is low, and then after that, when you take the waters from the low level of the reservoirs, then you have a lot of color that's in the water. Yeah, so this is where our membranes are absolutely able to remove. Remember, let's say in the southern part, there was also ammonia problems and so on and so forth, whereby, you know, unfortunately, there was an industry that actually threw some chemicals inside the water, and it caused the state of Johor to stop its treatment of its water plants and not able to produce water. So these are some of the opportunities that we are actually looking at, and so on and so forth. Obviously, there are more that we can actually do in Malaysia. And for all our friends, our engineering friends or consultancy friends in Malaysia, if you get my presentation, look up for my email and drop me a note. I'll be happy to talk to you guys, and hopefully, yeah, I can come back to Malaysia to see my own family. I've not seen my family for 2 years. Yeah.
Okay. You'll be back very much early.
Likewise, yeah. I have roots in both Johor and Penang, and unfortunately, although I'm just across the bridge where Johor in Singapore is, I can't cross that bridge and go home and see my family in Johor.
Understood. Yeah, probably one of the last one, due to time queuing at the moment, Allan, is that why do you think these membranes are different from others? And then, I mean, because of that, would the company be able to share the piloting, experience for fast scale up for your new product, as you correctly mentioned earlier? Yeah.
Oh, thank you. That's also a wonderful question. Yeah. To answer the scaling up and our piloting, yeah, I've earlier mentioned in my slides, we have 3 different sizes of pilots that we can offer to Malaysian companies and Malaysian industry, because we realize, yeah, this is a new technology. A lot of people have worked with UF and RO because these are so-called the rigors and standards in the last 20-30 years of membrane solutions. But talking about DNF, people would be like, apa ini? So that's the reason why we have 3 different sizes. We have a lab scale for those who want to test in a lab level. We have a mid-size one that we can actually produce up to 700 liters of water. And then after that, we have up to, the largest one we can do is called the MaxPert. Yeah, the mid-size one is known as Maxperience. The lab scale is the Maxplorer. The mid-size, again, is the Maxperience, which produces up to 700 liters, and the MaxPert will be producing up to 2,000 liters per hour. Now, what was the first question, the first part of the question?
Different from other manufacturers.
Okay. Now, we respect all our fellow industry mates. Yeah, the difference between us is that as a membrane manufacturer, by the way, we also manufacture MF microfiltration membranes. We also manufacture ultrafiltration membranes. But for this presentation, we are focusing on direct nanofiltration because we feel that this technology, the difference between this is that this is a combined technology. It's a combination of a UF and a half RO or 3/4 of an RO technology into one. In the presentation, you will notice that our technology do not require any chemicals. It is modular. That means today you are working on 10 cubic meters per hour, but down the road you're running at 200 cubic meters per hour, but we are still able to produce the water accordingly.
Okay. Aaron, I know we are not very tight, but there's one very important question there. Hopefully you can answer very fast. From Selihi, can the system remove ammonia in the water?
Yes.
Yes.
Straight to the point. Yes.
All right. I think then that concludes well. Straight to the point. It is the system can remove ammonia in the water. as much as we would like to share a lot more from Allan and Rick on this technology, I think we have to come to conclude the session, and all the questions that come later, that will be forwarded to the organizers, and the organizers will forward to you and Rick after the session.
Please keep your questions coming, gentlemen, ladies and gentlemen, and I promised you that I will reply you within 24 to 48 hours upon receipt.
All right, and for that, ladies and gentlemen, we are now at the end of our first track for today. And then for that, we will come back or forward back to our organizers. Thank you and have a nice weekend.
Thank you, everybody. Cheerio. Be safe.